In the late 2000s, after having been late for the 3G and 4G mobile revolutions, India wanted to be at the forefront of the upcoming 5G mobile revolution and bring fast internet to its more than 1 billion population. But they also wanted to do that using Indian technology and Indian equipment. BharatNet was the world's largest rural broadband project, using DWDM to connect 300,000 villages in India from 2013 to 2017. The Indian government employed CDOT, the Research Center for Development of Telematics, to develop telecoms equipment including DWDMs for the project. The United Telecoms Limited, a local Indian telecoms company, was selected to manufacture the DWDM equipment. CDOT is also reported to have signed technology transfer agreements with other Indian manufacturers like Indian Telecom Industries Limited, Tejas Networks, and Sterlite Technologies. The Indian government's gambit was a huge success. It helped the country connect more than 1 billion people to fast internet, while also helping build a local telecoms industry. While Indian firms are not yet global leaders like Huawei, Nokia, or Ciena, they play a significant role in their domestic telecoms infrastructure market and are expanding internationally. United Telecoms Limited is a privately held Indian telecoms and infrastructure company. Founded in 1991, it is headquartered in Bangalore, India. While it faced financial distress in the late 2010s, it has since restructured operations and is now a healthy company. UTL was helped by the Indian government when it was chosen for the deployment of a 50,000 km optical fiber under the BharatNet Phase 2 project. Strategic tie-ups with state-owned telecoms provider BSNL to provide 5G-ready infrastructure for rural 5G rollout also helped the company regain its foothold in the Indian market. It also now has contracts with private ISPs to expand fiber networks in underserved regions and holds about 5% market share in Indian government telecoms contracts. Locally, it competes with the likes of Sterlite Technologies, Tejas Networks, and HFCL. UTL's DWDM is labeled DWDM 100G OTN MSPP. Tejas Networks is a Tata Group company that offers end-to-end products and solutions for fiber broadband, 4G, 5G, DWDM, OTN, switching and routing networks. Headquartered in Bangalore, India, Tejas Networks is a leading telecoms equipment manufacturer. Acquired by Tata in 2021 through its subsidiary Panatone Fininvest, it operates under the Tata Group's umbrella, manufacturing telecoms infrastructure products like fiber optic cables, 5G radio units, switches, routers, and DWDMs. Founded in 1998 by Indian engineers, Tejas became a public company in 2017. It gained prominence through partnerships with Indian telecom giants like BSNL, Reliance Jio, and Bharti Airtel, supporting critical projects like BharatNet. The company exports to about 75 countries across Asia, Africa, Middle East, and Latin America, focusing on emerging markets with cost-sensitive needs. Tejas Networks' DWDM product is the TJ1600 series for metro, long-haul, and submarine networks. DWDMs come with special features. Let's explain some of these features. ROAD-M stands for Reconfigurable Optical Add-Drop Multiplexer. This feature allows wavelengths to be added, dropped, or routed on-site, making the system more reconfigurable and enabling network operators to remotely provision network traffic. FlexGrid. This feature enables variable channel spacing of wavelengths for more efficient spectrum use. FlexGrid is now mandatory for 800G and 1.6 TB networks. Proprietary DSP chips. Some DWDMs are powered by in-house designed custom chips that facilitate higher transmission speeds. Ciena's exclusive digital signal processor chipset is called the WaveLogic DSP. Nokia's is the PSE6 and Huawei is ODSP. IP over DWDM. IP over DWDM integrates IP routing within the optical layer. Ciena calls its version Adaptive IP, with Huawei calling its version OptiTrans OTN switching. Comparing DWDMs from public information is difficult, but units from Huawei, Ciena, Nokia, T8, and ZTE all seem to have top wavelength capacity of 800 GB per second per wavelength. The units from China's FiberHome and Indian manufacturers Tejas and UTL have less wavelength capacities at 400 GB per second. Huawei has a model with the highest number of channels at 120, and the rest of the companies have units of up to 96 channels. The maximum throughput for units of Ciena, Huawei, T8, ZTE is around 38.4 terabits per second. Most operators seem to regard Huawei and Ciena's offering the best balance between capacity and programmability, while Nokia provides the most flexibility and reconfigurability. When it comes to advanced features, Ciena seems to come up top with the WaveLogic chipset offering programmable modulation and adaptive IP, which integrates IP routing with optical layer. Then there is Huawei's OptiTrans and FlexGrid switching for efficient spectrum use. Nokia has the most advanced ROADM, CDCF ROADM, allowing unmatched flexibility and adaptability. ZTE and T8 follow with their FlexGrid ROADM OTN solutions. Ciena prioritizes digital signal processing over ROADM complexity, focusing on high-capacity transmission for long-haul and data center hyperscalers who prefer scalability over ROADM's flexibility. Nokia's CDCF ROADM is overkill for long-haul and data center interconnects. In the 2024 field trial, Ciena tested its WaveLogic 6 at 1.6 TB per second per wavelength over 470 km length. For metropolitan and telecom core networks that place premium on reconfigurability, Nokia with its CDCF ROADM and Huawei CD FlexGrid ROADM are your best bet. Huawei provides the highest density and the best balance for capacity and flexibility. Like Nokia, it has top-of-the-line reconfigurability with CD Plus ROADM. It also has the highest wavelength count, better enabling mixed-rate networks like 400G/800G. T8 unit also offers FlexGrid ROADM, but like Ciena, its units are best for high-capacity network transmission for long-haul and data center hyperscalers who prefer capacity and scalability. T8 has the best transmission range for long-haul performance with transmission distances of more than 4,000 km without intermediate signal regeneration, as it holds world records for long-haul transmission. ZTE has FlexGrid ROADM, allowing for efficient spectrum use for metro and telecom core networks, but it's not strong in long-haul like subsea data transmission. It has pricing on its side, undercutting its competitors by more than 20%. For the price, the Tejas Networks unit is very good value. Its features are a bit behind, but it's good for metro, regional, and core networks. DWDM sits at the foundation of today's networks. It powers the physical layer that carries all the data for upper layer protocols like IP, Ethernet, and OTN. By enabling terabit scale data transport over existing fibers, it ensures seamless connectivity to everything from telecom operators to global cloud service providers. DWDM allowed internet to grow exponentially without the need for constant digging for new fiber lines. Today, DWDM systems underpin AI searches, 8K video streaming, and virtual reality by delivering petabit level capacity. The first DWDMs that appeared in the 1990s transferred up to 1 terabit per second. The 2010s with coherent optics transferred 20 terabits per second per fiber, and the 2020s with special division multiplexing SDM is transferring about 100 terabits per second per fiber. Ciena will soon be introducing the next generation of DWDMs, moving from 800G to 1.6 terabits per second per wavelength. A new company, Mavel, has introduced a 3nm Mavel Ayar chip that supports 1.6 terabits per second, offering higher performance whilst reducing power consumption. In the near future, companies like Ayar Labs with optical I/O chips are merging photonics and semiconductors to offload some of the functions of photonic processors, thus increasing speed. Intel is also creating silicon photonic transceivers by integrating CMOS with photonic integrated circuits. DWDM will remain the backbone of global connectivity, evolving with innovations like photonic integrated circuits and machine learning-driven network optimization. Its creation marked a turning point in telecommunications, making the modern internet economically and technically feasible. Subscribe and stay tuned.